In this video, we're going to learn how to show triangles are congruent by using two postulate. Remember postulate just means a commonly stated statement, and usually it's proved somewhere else, but it's by extension everybody agrees to it. So let's see what we have in details here. Here's a side-side-side congruence postulate, and we use SSS to represent that. So what it says is that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So if three sides are congruent to their corresponding sides in the second triangle, then these two triangles are congruent. And here's an example. Triangle MNP and QRS are congruent because notice how each side is congruent to the corresponding side in the second triangle. So therefore the conclusion is MNP is congruent to QRS. Again, be mindful of the sequence of these letters. Okay. Let's use SSS to help us. Does the diagram give enough information to use SSS congruence postulate? The answer is yes. Why? Because in order to have SSS, I have to have three sides be congruent to the three sides in the second triangle. Notice that I know HJ and LJ are congruent. I know it's given HK and LK are congruent. So far I have two sides, but the third side is a shared side. JK obviously is congruent to JK by itself. And in fact, there is a word for this. It's called reflexive. Reflexive property. What is a reflexive property? Reflexive property is basically you're looking at your own reflection. You're standing in front of a mirror, and the person inside the mirror is exactly the same as the person standing in front of the mirror. So JK is congruent to itself. That's reflexive property. And therefore now I have three sides being congruent by SSS, and that's totally legal. I can make a congruent statement to say HJK triangle is congruent to triangle LJK. Okay? So that's how we use SSS. Now, here's another postulate called SAS. If two sides and the included angle, of one triangle are congruent to two sides and the included angle of a second triangle, then these two triangles are congruent. So look at these figures here, PQR and WXY. They have two sides that are congruent. PQ and WX are congruent. QR and XY are congruent. Then the angle sandwiched in between is called the included angle. So these are congruent as well. So angle Q and angle X are congruent as well. So I have a SAS situation. Then I can say PQR is congruent to WXY, triangle WXY. Let's do some examples here. Does this diagram give enough information to use SAS, congruence triangles? So remember to have SAS, I have two sides and an included angle. And in A, I have AB is congruent to BC. That's one side. And again, I have a shared side. So BD is congruent to BD itself, and that's read by reflexive property. Then I have angle DBA is congruent to angle DBC because they're both 90 degrees. And so by SAS, triangle ABD is congruent to triangle CBD. Again, you've got two sides and you've got a sandwiched angle, SAS. So that's how you prove it. This one, you have one side, you have one angle, HEG is congruent to FEG. Okay, one angle. And you have one side, GH and GF are congruent. You do have a second side. Oops, you do have a second side here. But be very careful. You do have a second side. GE is congruent to GE. But notice that this angle, HEG and FEG, is not sandwiched between the two congruent sides. It's on the side. And therefore, I don't have enough information. Not enough info, because you need SAS, and you need the A to be sandwiched between the two congruent sides. Okay? And here are some steps to write a proof. We went through this in class. To write a proof, you need to list the given information, and this is two-column proof. So you have to list the given information. Then you decide whether you can use the information to derive new information. Then you list all of your statements in sequential order, meaning you don't want to have any disconnect. You list a reason, you list a statement, then you write out the reason. And then the first statement leads to the second statement, you have to list out the reason. And you have to give a reason to every single statement. And the reason can be definitions, can be given informations, can be the labeled diagrams, postulates, etc. And finally, you end it with the statement that you are trying to prove. That's the process. You've done it a couple of times already. You're going to get really good at this. In this example, we're asked to prove if the triangles are congruent. Because we're asked to write a two-column proof, you always want to write down statements on the right, reasons on the right. Statement on the left, reasons on the right, and you always start with the given information, and that's the setup. So then now you fill in the blank for given information. What you know from the diagram is LJ is congruent to HK. You know LK is congruent to HJ. So in other words, two sides are congruent, and both conditions are given by these markers right here. Right? So once you write down the given information and you look for what else do you need in order to prove the two triangles are congruent. You have two sides already. You can look for angles or you can look for an additional sides. And in this case, it just happens so that JK is the shared side, the common side. And JK obviously is congruent to itself. And this is called the reflexive. That's an X. Reflexive property of congruence. Now I've got 3 sides being congruent. I can draw the conclusion that triangle JLK is congruent to triangle KH. I'm sorry, my sequence is wrong. It's congruent to triangle JHK. These two are congruent, and that's by SSS congruence postulate. Okay, so that's how we write 2-column proofs. Here's another one. We are asked to prove that these 2 triangles are congruent. So again, if you're asked to prove it, start the 2-column proofs with statements and reasons. Always set it up like this, and then find out what's given. Let's see what's given. We know that DR is perpendicular to AG, and RA is congruent to RG. So those are given. And RA is congruent to RG. Okay, so immediately we recognize that we have an S here already, right? And I need to find more information. Now, if DR is perpendicular to AG, that's telling me that the angle, the angle of ARD is congruent to the angle of GRD. They're both 90 degrees. And so this gives me an A, right? Gives me an angle, a pair of angle being congruent. Now I look for the third thing. Notice that if my focus is this right angle, then my next thing, logical thing to do is to make sure that DR is congruent to DR, and of course it is, because this is reflexive property. I forgot to mention that this 2 angles is definition of perpendicular angles, right? If they're perpendicular, that means the 2 angles are 90 degrees. I forgot to mention that. So this gives me another side. So finally I can say by SAS, I can make the congruence statement that ARD is congruent to triangle GRD. Or in their language, DRA is congruent to DRG. Either way would work. Okay? I think that's it. After this one, make sure you pause the video and try this one on your own. I'll see you in the next video. Thank you, guys.